Hello everyone, Yicheng here. Today we will continue our demo on the buck converter. Here is the buck converter demo board that we showed last time. It is currently operating at an input voltage of 10 volts and an output voltage of 3.3 volts. The load current is set to be 0.8 amps. On the screen of the oscilloscope, we can see that the inductor current, which is shown by the yellow waveform, is always positive. So we say that this buck converter is operating in the continuous conduction mode, CCM. Now, we know that the inductor current is composed of two components. It has a DC component, which is equal to the load current, and the ripple component. And in the previous demo, we implicitly assumed that the ripple component is smaller than the DC component, so that the inductor current never drops to zero. But what will happen if we reduce the load current so that the DC component becomes smaller than the ripple component? Okay, well, the inductor current becomes negative. That is what we're going to see in today's demo. So now let me start to gradually reduce the load current from 0.8 amps to a smaller value. Now, as you can see, when I reduce the load current to be roughly 0.35 amps, we can see that the minimum inductor current hits zero. And so now we are at the boundary between the continuous conduction mode and the new operation mode that we are going to see. Now let me further reduce the load current to be roughly 0.1 amp. Okay, so now as you can see, the inductor current will drop to zero and it will stay at zero for a certain period of time during each switching cycle. And so we say that now this buck converter is operating in the discontinuous conduction mode, DCM. In this discontinuous conduction mode, as we can see, when the high side switch S1 is on, the inductor current rises. And when the high side switch S1 is off, the low side switch S2, which is a diode, is forced to turn on, and the inductor current falls. After that, the inductor current will stay at zero until the high side switch S1 is turned on in the next switching cycle. One thing you might be wondering is why there is ringing on the switch node voltage waveform. That is because when both the high side and low side switches are off, the parasitic capacitances of these two switching devices will resonate with the inductor, and this resonance actually causes the voltage ringing on the switch node. All right? So that's all for today's demo. Thank you, and see you next time.